OSA and TCP comparison. So, but we are not using OSA model or any other model, guys. We are using TCP IP model. We are all using communication through using TCP IP protocol suite. And mostly we are using star topology. Mesh topology only used in server side or a router, core router side, core server side, SAN storages. They may some places use this mesh topology, but we are all using star and extended star topologies only. Okay, and because we are not only IP TCP IP protocol, so also we are using IP address type of addressing only, logical addressing in the form of IP address only. We don't use IPX, SPX, Apple talk kind of stuff. Okay, that's why most of my notes, even though OSA model or any other things where we are discussing, I didn't told about those things because of we are not using, and that too our public communication, private communication. Okay, we are all globally we are using IP addresses only. That too IPv4 only we are using. Some organizations, mainly private type organizations and certain countries using IPv6. Okay, so what is this IP address? IP address is a logical address which we are already discussed in the first classes only. But again, I'm telling IP address is a logical address. IP address is uniquely identify a device in the network. IP address is a logical address. IP address is uniquely identify a device in the network. IP address is not a unique address. It is a uniquely identified device in the network. IP address can change according to the network. Guys, I connected in my home. Today I'm in my home, so I connected to my home network. From my router, I will get a certain kind of IP address. On Monday, I will go to office. I'll connect to office network. Then I will get another kind of IP address. Okay, I will get another kind of IP address. Okay, so these are the simple things. I have a devices to communicate in the network. Every device required an IP address. So here we are discussing address. Yeah. Just remember, IP address is a IP address is a logical address. So when you say IP address, it is uniquely identify a device in network. It's called a IP address. Guys, when you are able to tell, like when you want to tell about what is an IP address, but sometimes people will tell, it's a unique address. Why should we spill a big sentence? Better we give some explanation. Better we tell a very big things. Unique address, guys. IP address is a not unique address. MAC address is a unique address. Okay, so compulsory no, it is not unique address. If you are unable to speak this complete sentence, don't speak also, no problem. Instead of telling a wrong answer, better to don't tell a certain this kind of stuff. Okay, so better go with the other simple things. Okay, to communicate in network, the devices need IP address. Both the devices. Remember, all communications by IP address only. Okay, we cannot communicate with the other means. All communications by IP address only.
Sir, I have a question.
Tell me.
Yes, sir. So why don't we use MAC address only? Because MAC address are unique. So why not use directly MAC address? Why assign IP address and then use it?
Because we
No,
have to divide a network logically. We cannot divide them. We can divide them in physically, but you have to treat any network as a logical way only. So logical way of communication is there. Okay. So physical community, physical with physical IP address. Sorry, the physical address is MAC address, right? So with physical address, we have a lot of confusion in it because one NIC, the NIC part, IP part, understanding of this physical addresses is little difficult in the network. Creation of multi-network kind of stuff also difficult with the physical one. Okay, yeah, it is not satisfaction answer. Um, in general, I'm not going to reasons. First of all, when you are pinging to some PC or some new remote system or device, we use ping IP address only because IP addresses are divided into the logical network, means network and host part. In MAC addresses, there is nothing like that. In MAC addresses, also two parts are there. First part is manufacturer of NIC. Second part is
so
sequence address. Yeah, tell me.
yeah, what I want to say is from one network to another network, we can use IP address. That is fine. But when we are connecting from a network to machine, directly to machine, a hop to a computer, so then we can use MAC addresses only. Why we need to assign IP
Yeah,
address?
I got it. So generally, within your local network means your LAN network it is there. So why we don't require any IP address? So simply can communicate with the MAC address, right? So because same logical network, same network it is, same physical network, not one to another network, same network it is. So we can use MAC address to communicate. That's the question, right? Yeah, that is
Yes.
also same thing. So in the same logical network also, again we can divide the same logical into separate, sorry, same physical network. We can divide them into logical network with IP address. So logical addressing is compulsory anyway, logical address. But there is one thing is there, guys, that is called a link local IPv6 address. Link local IPv6 address. If you don't have any DHCP server or if you don't want to configure any IP addresses, no problem. Because this IPv6 address generate a IPv6 IP address using your LAN, your MAC address, your NIC's MAC address. Okay.
Okay. So that's a different concept altogether if you want to use that.
Yeah, like now you don't want to use IPv4 or you don't know how to assign IPv4 address. No problem. Your adapter. So, for example, this is my adapter. My adapter having an IP address, see, link local IP address. This IP address I didn't assign. It is assigned automatically to this adapter based on this MAC address. So we can communicate with this IP address. Again, we have to communicate with IP address. And one that is good. Okay, that part. But lot of things are there. That actually lot of things are there. When you create a IP address in the sense of IPv4, okay. So for example, this is PCA. PCB. So you can easily understand names. Name wise you can able to communicate. So we can understand names very easily, but in network, not names, only IP address, right? Names we can easily understand. If you can able to communicate with the names, that is good, but we can't use the names. Another unique one is your MAC address. How many people are able to get other PC's MAC address very easily? Can you able to understand? Just this is for answering you. Okay, really not a reason, but still MAC layer is a down layer. Okay, see this is. Can you able to remember this one? Can you able to remember this one? 10.10.1.11. This is difficult, right? Okay. For example, other PC is there. Another PC MAC address is this one. Can you able to remember this number?
A bit difficult then. That
Yeah, bit difficult. You have to write down first of all, right? You have to note down this MAC address. But once you are habituated, see it is. I show 10.10.1.110 for example. This is 1.111. See it is two PCs, two IP addresses. I want to ping from A, ping to B, ping to B. Very simple, right? Once you read it, you will remember. Once you will understand, so we can easily type it. So just for
so what you want
answer
to get a range of network, so we can understand what is the range, and then we know how many IP addresses are there and
yeah,
what are the IP.
you told answer, original answer. That is, the range is fixed range will be there. Number of PCs in the ranges. Okay, in this range, number of PCs are connected, and their network part, their host part is there. Network must be same, host must be different. So that kind of logical addressing. So based on that, this is the network, we can able to communicate through this network kind of stuff is there. Whereas a MAC address, there is a no network part, no host part. It is only identify the NIC. It is a only identification of NIC only. Okay. Of
Oh,
course, IPv6 is created from MAC address. It take the MAC address and create IP address. But IP means logical. These addresses are definitely logical address. Okay,
okay.
but difficult to remember. Okay, don't get confused, guys. All communication with the IP addresses only, not with the MAC address. Okay. This is PCs. As I said, every device, whether it is connected to with wire or wirelessly, not a telephone, then important is we should communicate through just normally I am telling this is a star topology type. Okay, we are connecting these devices. So this is a PCA, PCB, PC, D. Okay. So as I said, each and every PC must have an IP address. For example, 10.0.0.11. Little for to save time. Okay. So if you have a IP address, then only we can able to communicate from one PC to another PC in our TCP/IP networks. In our TCP/IP network, we can able to communicate from one device to another device with IP address only. Maybe if you are using different type of protocol suite, then maybe it will communicate in different way. Okay, so these are the point, guys. IP is logical address, uniquely identify a device in the network, and to communicate in the network, so we need a IP address. To communicate in a network, you should require you and your destination PC both are required an IP address. Definitely, IP address and MAC address difference is important. Okay, but we don't have a time to discuss those things. Okay, so I will go with in IP addresses, IPv4. Already we discussed, that's why I'm not telling. This choice I'm giving to you guys. Already we discussed, please check it once. IP address and MAC address differences. Okay, so I'm giving only IPv4 part. I think this part also we discussed. IPv6, but small things, guys. It is IPv4 version 4 is 32-bit. Okay, it is a 128-bit. Okay, small differences I will tell, but I will tell about IPv6, just basic things only. So total IPv4 addresses, are 2 to the power of 32. It is around 4.3 billion IP addresses. You will get it. 4.3 billion IP addresses you will get. If you go to calculator, then you can try this kind of stuff like standard or a programming kind of stuff. No. Yes, scientific calculator. 2 to the power of 32. See, it is around 4 billion IP addresses. You will get it. This is the total size of your 4 billion IP addresses. Why this is 18, 14. Okay, so this is the total size. But if you take 2 to the power of 128, it is a 3.4 billion IP addresses. We will get it. So original number is, okay, so 3.4 into 10 to the power of 8 IP addresses we are getting in a IPv6. Okay, yeah, if you want to calculate, you can calculate like a 2 to the power of 128. Remember, guys, 128. See, it is, yeah, so sorry, there is a mistake. 2 to the power of 128. See, it is E plus 38 means 10 to the power of 38. 4.3 into 10 to the power of 38. So IPv6 will write, okay, so IPv6 in decimal format. We'll write in a decimal format. Whereas IPv6 we write in a hexadecimal format. Okay. How IPv4 is look like? So you can see an example of IPv4 192.168.1.123, something like that it will shows. Whereas IPv6 very big one. Of course, different IPv6 are there. IPv4 any class it look like same only. only, but IPv6 look differently based on the different categories. But I'm giving most common way 2023. Something like 1, 2, 3, yeah. Okay. Okay. Totally, I need these blocks are 8 blocks, guys. So these are the 4 blocks completed. 2 more blocks. Sorry, 4 blocks. This is 6 blocks. I'm telling. Okay. Some people think it is alphanumeric. No, guys, it is not alphanumeric. It is hexadecimals. Hexadecimal format. Okay. So this is IPv6 hexadecimal format. Okay, this is how it is. IPv6 is look like. Okay, IPv6 can be in a different formats, but this is a one of the common format. Okay, so next, guys, this IPv4. Just I will tell about IPv4 first small parts. See, this is IPv4, which is divided into 4 parts. Okay, so IPv4 total is divided by 4. Divided by 4 parts separated by dot. Okay, so don't say point, it is a dot. Okay, so means it is a totally 32 bit divided by 4 means each part is 8 bit. Each part is 8 bit, which is nothing but a octet. Which is nothing but a octet. So 2 to the power of 8 means 256 is a 1 octet size. Meaning is 0 to 255 is your octet size. Okay, is your octet size. Means 0 to 255. So each octet is not more than 255. Each octet size is maximum 255. Each octet size is maximum 255, not more than 255. We have a 4 octets. Okay, we have a 4 octets. Okay, so this is like that. The first octet called as a first octet. Okay, the second octet called as a second octet. Third octet called a third octet. No, for fourth octet called as the fourth octet. First octet, second octet, third octet, and fourth octet. So this is like this. For some people, for convenience purpose, they use these terminologies. For example, W, X, Y, Z. They use W, X, Y, Z. W means first octet, X means second octet, Y means third octet, and Z means fourth octet. So some people use this terminology. Both are same, guys. Depends upon how easily we can able to understand, how we can able to work at a understanding level. Okay. So again, your 32-bit is divided into 4 parts separated by dots. So it is each part is 8-bit, that is called as a octet. the size of octet is 0 to 255. The maximum size is 255 only. So each octet contains 0 to 255, not more than 255. The first octet is called first octet, second octet, third octet, fourth octet. You know, the first IP address is 0.0.0.0. The last IP address is 255.255.255. Now these IP addresses will start like this: 0.0.0.0. The second one is 0.0.0.1, 0.0.0.0.2. It keep goes 0.0.0.254. Then it is at 0.0.255. What is the next one? What is the next one? Zero dot 1.0, like a numbering system only. 0.0.1.1, 0.0, 1.2. Keep goes 0.0.1.254, 0.0.0.1.255. What is the next one? 0.0.2.0 was 0.0.255.255. So what will happen? 0.0.1.0.0. So it keep us going on like that only. So 1.255.255. Then what is happen? 1.0.0.0. Okay. If you go to like this, 1.255.255.255. What is the next one? 2.0.0.0. Okay. So like this, it keep on going on. So finally it will reach us. One second, 0.0.1. The same way it is go to 0.255.255.255. So what is the next one? It is okay. So that is finally it will reach 2.0.0.0. So it will happen finally. So like this. Okay, finally it will reach. It is look like this one. So okay. So this is the total range. This is the total range, guys. I didn't told about more thing about IPv6, but small things I will tell about IPv6, guys. IPv6, guys, hexadecimal. One hexa number is equal to 4 binary bit. Okay, one hexadecimal is 4 binary bit. 128 bit by 4 means almost 32, not almost 32 hexadecimal numbers. 32 hexadecimal numbers. Okay, guys, these 32 hexadecimals, sorry, 4 hexa numbers grouped together become a one block. here it will become a one block. One block. It means meaning is so 30. So 4 hexa numbers as a one block. As a one block. Okay. So how many blocks are there? Totally 8 blocks. Totally 8 blocks are there. So separated by colon. Separated by colon means like this. Okay, 8 blocks separated by colon. Okay, so that is how it is. 8 blocks are there separated by colon. Hexadecimal number, 32 hexadecimal numbers are there. Okay, then it is each 4 become one colon kind of stuff. If I write again, it will become very bigger one.
So do we use it practically?
Yeah, we can use practically. It is implemented already. 1/16th part is implemented in IPv6, total IPv6. That 4.3, sorry, 3.4 billions of IP addresses. Out of that one, 1.6 IP, 1/16th part of IPv6 already released into the public. We are using IPv6. Okay.
In hexadecimal.
Hexadecimal, yeah, with hexadecimal. IPv6 look like very complex, guys, and very difficult to remember IPv6 addresses. But one thing is IPv4, we have to manage lot of things. We can remember, but we have to do lot of things, including DHCP server addresses. So many things you have to do managing that IPv6. For a user or a people just using a network, so IPv6 is not like it is a mostly stateless mode. Okay, just if you give a range, automatically devices will configure IP address. Local is there, remote is there. Okay, so guys, look at here. So I will try to finish. Your IPv4 addresses, starting address is this, ending address is this is the your total IPv4 address range. Okay. If you are comparing while learning, you are comparing IPv4, IPv6, lot of confusion because IPv4 is the working the way the divisions are different. IPv6 way of dividing IP addresses are different. Not only 32-bit, 128-bit decimal format, hexadecimal format. Okay, so not only those things, lot of differences are there that we cannot use comparison part. So that's why I'm concentrating on IPv4 part only. So IPv6 still some few more points also there. Okay, we'll see that one or two points I will include here also while I'm telling. The total range is 0.0.0.02 255.255.2. This is the total IP address range. 4.3 billion IP addresses. Okay, or this total range is divided into 5 classes. Okay, it is based on first octet. Class is based on the first octet. Okay, So we'll see what is that first octet. First of all, what are the classes? Class A, class B, class C, class D, class E. So totally 5 classes. Guys, there is a binary numbers also there. So if you cannot able to remember binary, no problem. Remember the other range is also there. Guys, IP addresses start with a 0, right? So this is the first octet part. Okay, this is the first octet. This is starting IP address. The first octet is 0. The 0 in the form of binary, right? 0 in the form of binary. It is 8 numbers are there. 8 zeros become 1 0. This is octet, right? 8 0 represent 8 zeros. So what is the class A range? The starting with a 0 0 0 0 and the range means first bit will be in a class A, the first bit be same, no changes in the first bit. Okay, first bit is same, no changes in it. Remaining become ones. Okay, remaining become ones. So in decimal, it is 1 to 127. If you check in some textbooks, it shows 1 to 126 because of there is a reason. Okay, so we can't assign these things to NICs and reserved. Zero dot zero dot zero dot zero. It is a reserved. It is a reserved IP address, also called as a unknown. Okay, unknown as used in some services. Certain services instead of certain I put it like DHCP client services. Okay, so they use in a DHCP default routing. Using this 127.0.0.1. This is also reserved IP address. It is a local host. Right? Loop back IP address. Guys, any which ways the 0 series we don't use it. 127 series also we are not using. Okay, we cannot assign. Using means we cannot assign to any adapter. I will tell about 127.0.0.1. Okay, so either we should draw it or this is a better. Guys, I have my own PC. My PC has an IP address, IP config. See, this is my PC IP address. Not my PC IP address, it is my adapter's IP address. See, every adapter having some IP address like that. My PC also having my adapter is also having a IP address, right? IP address, subnet mask, default gateway. For example, I have a PC, right? So this is having an IP address. For example, it is a 10.0.1.11. This is also having an IP address 10.0.1.12. Okay. This is A and B. I want to send a packet A to B. How to do it? For example, ping command. Ping 10.0.1.12. Right? So A to B communication I am sending from one PC to another PC. So this PC name is A and this is an IP address. Okay. But here every PC has their own IP address is their local. loopback localhost IP address is there, that is 127.0.0.1. In BPC also 127.0.0.1. This PC having this IP address, this PC having this IP address. And they have their own name, like instead of A, their name, this PC name is localhost. Okay, of course, A's name is there, but also another name is localhost. This PC name is also localhost. Guys, my name is Latif. So you want to call me, so you will call with my name, right? If I want to call to myself, if I want to call to myself, then how I call myself? Myself only, right? So I don't require a name for me. Why I need a name? If people should recognize me or call me by name, right? A want to communicate it to B. So A PC need a name, that A, the B PC name, that is B. And both require an IP address. A PC IP address, B PC IP address. A send a packet to B or ping to B means ping with a destination IP address. Means one to another communication, okay, in unicast way, that is this IP address. Okay. But what is the use of this one? It is a self type. A's IP address and B's IP address is also same. For example, from A, I'm pinging to 127.0.0.1. To who am I pinging? From A, I'm pinging to A only. Means localhost only you're pinging. For example, in BPC, I have a certain service is there, guys. Some web application is there. Okay, some web application or a database application is there. I want to access through network from B. The BPC contains the client application. So this is web application, client application. In a client, I can use 127.0.0.1. If I use in a client, I use 127.0.0.1 means I want to connect to the same PC. I have a client application in the APC also. This is also having client application. How to connect? 10.0.1.12. See, you are connecting from different PC. It means we need an IP address. You are connected to yourself. There is a IP address called a localhost address 127.0.0.1. You still need a proof. This is my IP address. See, I am pinging to my. You have to ping with IPv4 -4. You want to ping with IPv4 -4. See, it is my PC showing 127.0.0.1. I want to ping with IPv6 like this. So my localhost address is ::1 in IPv6 127.0.0.1. Is it? Okay. Said now I will tell in IPv6. It is ::1 in IPv6. Localhost or loopback IP address. In the IPv4, this is in IPv6. That's why 0.0 series and 127 series we are not using. That's why some textbook shows 1 to 126. Next address is 10040 kind of stuff, in which ways the first two bits are same and remaining become ones. This is the next one. Next one means after this is the next number. After this is the next number. Okay. If you don't know binary, it's okay, no problem. First one is only first bit is same. In B, first two bits are same, remaining changes. In C, first three are same, so remaining become ones. So last ranges we are calculating. That's why it is 127, 223. Is the next one. First four are same. All are ones. All are ones means it is 255. Remember, all ones means 255. All zeros means 8 zeros means 0. 8 ones means 255. So 0 to 255. This is the class A, class B, class C, class D, class E ranges. So this is total IP addresses we divide into different classes. And there is a question, why we divide IP address into classes, guys? So there is a several reasons are there. So we need a certain reserved IP addresses also. Plus, you know, class A, class B, class C also network wise different size of networks it is providing. So compulsory depends upon user. Uh, Guys, are you able to see my screen now?
Yes, sir.
Yes, sir.
It will do.
Suddenly
Yes, sir.
disconnected. So like a internet is disconnected type. Something happened, we don't know. So now a network is working, app is working. Okay. So these are the classes and ranges. The class E is called R&D. Okay, people put a very simple R&D. It is special cases only used in some places Aristotle kind of stuff. The class B is important, guys, because it is a multicast. This multicast and class D we are not using. We don't assign to multicasting IP address. Okay, it is multicasting IP address. We don't assign to NICs directly. We use it, but we don't assign. We don't use it. Don't use this kind of stuff. Okay. Class A, Class B, Class C are a unicast IP addresses. Okay. Are a unicast IP address. This is for a unicast purpose. Class A, Class B, Class C. So 3. These are all unicast IP addresses. This is multicasting. This is RMD. Okay. So only small details I will tell because remove this part. Guys, class A range is 0 to 127 or a 1 to 126. Class B range is 128 to 191. Okay, how to remember? Try it. If you cannot remember, by heart it. I don't mind about anything. Okay, so if you keep practicing, then only we can able to remember. Okay, you have to keep practicing. What is those things and all. Okay, so this is class A 0 to 127, class B 128 to 191, class C 192 to 223, class D 224 to 239, class E 240 to 255. Compulsory. It is not just a display purpose. Compulsory. You should know these classes and their ranges. The first class A, class B, class C are a unicast IP addresses. These are the unicast IP addresses. Okay. So I'm removing this part also because it is already information is there. What is class A 0 to 127, class B 128 to 191, class C class C 192 to 223. Okay guys, so here it is the subnet mask for a class A 255.0.0.0, for a subnet mask for a class B 255.255.0.0, for a class C subnet mask is 255.255.255.0. Okay, this is a default subnet mask. I'm giving a default subnet mask to you. Default subnet mask used only for class A, B, C only. No subnet mask for the remaining things. Because there is some more details are there, because I'm not sharing that one, so that's why it is. It looks like a small. Hey, what is this? It is a, these are the default subnet mask of a class A, class B, and class C. Okay, so network and host portion part is there. So I'm not telling that one now because we don't have a time. Okay. Yeah. What is the default subnet? What is subnet mask? I will tell. Okay, guys. Subnet mask divides IP address into network portion and host portion. Okay. So the IP address divide a network into host portion and network portion. Okay. Subnet mask tells what is network ID. Okay. So what is the use of this network ID? If two devices communicate each other can communicate each other their network ID is same. Two devices, the two devices, two or more devices can communicate. Two or more, two is the best option. Two or more devices can communicate each other if their network ID is same. Network ID must be same. Okay, must be same. Then only they will communicate each other. So who will tell the network ID? Subnet mask. So I'm not giving that details, but this is a subnet mask. Okay. What is subnet mask? Subnet mask divide IP address into network portion and host portion. So subnet mask tells what is the network ID. So if same network ID for two devices, they will communicate each other. Guys, better to follow once this subnet mask part in this PPT. Okay, that's what I'm trying to say. You know what is this network portion? By default, the first octet is network portion. So remaining octets are in a class A or a host portion. Means if you are using a class A IP address, for example, you are using a class A IP address. Look at here. So I'm using class A IP. Yeah, I'm using a class A IP like a 101 means 100. What is this? 22. Which class it is? Class A only, guys. If you see 100, class A. Okay. So what is the network portion? 100 is the network portion. Okay. So what is the remaining is this is the host portion. This host portion. For example, I have another network. What is why this is? It is 100 is a network portion. 34, 55, 123 are a host portion. So both will communicate each other because of their network portion is same. Because of their network portion is same on that. Same goes for a class B, guys. The class B, the first two portions are network portions. Remaining are a host portions. So how it is? For example, you take a class B. 150 means class B only. Okay. And I have another device. Host portion can be anything. Host portion means just like a roll number. Okay. For example, guys, I will tell this host portion, network portion kind of stuff. Listen carefully. Okay. I'm creating one numbering sequence. For example, your batch is Noida 11 batch, right? N11 batch. Batch. The first person, I put a 1. Okay. Second person. Okay. What is this meaning? So remove this N. For example, for Noida also, I have some numerical representation is there. What is this meaning, guys? Batch 11, roll number. So for all these people, same, right? For example, if I put a 10, 0, for example, I put like this. Who is this? So obviously this is a 10th batch. This is 11th batch. Both are different. Both are different. So this is a roll number, but this is a different batch. So for example, that is simple to understand what is a network and host portion. Okay, so compulsory network portion must be same. So then only it is belongs to same logical network. If different logical network, so this is, for example, this is 150.24.100.24. So it is different network. So I'm keep going. So I want to stop for you, but I'm not able to stop. It's a different one. If you check it, different one. So you cannot communicate. It won't work here. What is the network version? 151 and 23 is there. But you can see this 151 is not a 150. 23 is good, but 151. Again, this is also won't communicate each other. So like that, we can understand network and host portions and a subnet mask. Subnet mask calculation is different. Class C, network, host portion. So first three portions are a network portions. For example, you take what is the network portion? Class B, this is a network portion. Okay, so like that. And what is the use of, guys? A host means one octet, right? Host, can you see? It is a one octet. One octet means 8 zeros. 8 zeros. Okay, so 8 zeros means 2 to the power of 8, 256. Okay, 2 to the power of 8, 256 minus 2, it is 254 devices. You can connect one single class C IP address. How it is? Can you see it is my 192.168.1.0. This is my network ID. This is my network. Network will start from here. This is my network ID, which we cannot assign to NIC. Okay. So remember, this is starting IP 192.168.1.1. This is the first valid host ID. Means we can assign to your PC NIC 192.168.1.2. So it is keep going. We can assign up to 192.168.1.254. This is the last valid host ID, IP address it is. So up to here we can able to assign 192.168.1.255. It is called a broadcast ID. Again, this is we cannot assign to NIC. Okay. What is the next one? This is 192.168.2.0. Again, network ID. And this is a different network now. Okay. This is different network. This is one network. This is completely one network. This is a different network. See, this network ID is changed. You can see network ID is changed. This network ID is different. This network is so another network. This is one single network. Out of this 0 to 255, 0 and 255 we are not using. So obviously it is -2. Okay, 254. Same goes here also. Class B, guys. So 2 to the power of 16, because 2 heads are there. 2h means 2 host portions, means totally 16 bits. 2 heads are there means minus 2. So it is around 64,534 is the result. And this is a 3 heads are there. 3 heads means 3 8s or 24 minus 2 minus 2. Okay, so this is 16,777,214. Okay, so that is a level. Somewhere it is written. So these are all information is good here. So 16,777,214. So like you can use million wise or thousands, lakhs wise also you can write it. Means you have a 50 computers. Class is best. You have a 5,000 computers are there. Means more than 254 computers are there. Class B. Up to 65,000 devices we can connect in a one single Class B network. One single Class B network you can connect. Means without changing this part, you can connect 64,000 systems. So same way, same thing I'm writing here, guys. So see this, without changing this first part, we are getting 254 devices, right? Same way, see it is Class B. This is network part. So network ID. So 150.23.0.1. So this is the first valid host. It continues 150.23.0. What happened this? Why suddenly it is working differently? 23.0.23 to keep goes right. So like this 150.23.0.255 still valid. 1.0, okay, still valid. It is 150.23 1.255. So 150.23.2.0. So it keep goes like this. It goes like this. 150.23 255 254. After this is valid range only. There is a last one is there, that is broadcast is there, that is 150.23.255 it is a broadcast ID. Okay, so this is the very big range, right? So two host versions, 65,534 devices we can connect in a single Class B network without changing these first two octets. Entire things we will get it in the first version. Same goes for Class A. First portion is network portion. So first portion don't change, remaining portions will change. Almost 16 million devices we can connect it. That's why we are divided IP address into different classes. Okay, these are network and host portions. What is user subnet mask I told. Okay, so I have written these things. That's it. That's enough for you guys. But there's small points are there. I will tell on Monday. Okay, that's it for today. Okay.
Thank you, sir.
Thank you guys. Thank you.
Thank
So
you, sir.
private IP address is there. I will tell private IP address on Monday. Then I will start new topic on Monday. Thank you guys. Bye bye.
Sir.